Welcome everyone, 3 o'clock. It is actually 14th of July. Who scheduled a meeting on 14th of July? Where we're not all in the beach right now. Today is a very special day for EPIC. It's our first online technology meeting in cooperation with the Mid-Infrared Alliance. All the companies on this huge boom between 3 to 15 micrometers working together and trying to find partnerships. We're going to do industrial manufacturing today, but we're also going to do security and surveillance. We are also going to do medical, and we're also going to do environmental monitoring. We want to make sure that the industry knows about this huge boom that the mid-infrared technologies signify. The Mid-Infrared Alliance is the industrial collaboration between companies that are working in the wavelengths between 2.5 to 15 micrometers. We are now ready to announce the details of the first technical focus meeting. Let's start with one of the biggest application fields, industrial manufacturing. Mid-infrared has already made a big impact in the laser-based industrial manufacturing world. CO2 lasers are a mature technology that is already very well established. Companies like Coherent, Prima Power, or Trumpf are very well known and trusted brands. Yet, there are still challenges related to beam shaping and beam delivering. Let's discover those needs and match them with solutions offered by the Mid-IR Alliance. Think about input from specialty optical fiber companies like Lever-Fleuret, Coractive, or Art Photonics, to the mid-IR optics of Iridian or LightPath, or the beam shaping capabilities of K-Labs, just to mention a few. But what if we go beyond CO2 lasers? What makes me extremely excited is the launch of a new generation of mid-IR ultra-fast lasers down to femtoseconds to be used in industrial manufacturing. Look at the examples from newcomer Femtum. Why am I so excited? Because when it comes to consumer products like the phone in your pocket, it is all about thin film patterning. It turns out that mid-IR pulse lasers are ideal for thin film patterning. That's because most conductive thin films are based on oxide materials that strongly absorb 3 micrometer wavelengths. That means mid-infrared is ideal to selectively remove these thin layers without affecting the substrate. But another crucial aspect in industrial manufacturing lies in real-time monitoring, because recalling a product these days can cost millions. For example, during a laser welding process, any changes to the process parameters will affect the size and properties of a welded joint. Constant monitoring is essential, and there are many ways of monitoring that with thermal cameras. What is the best wavelength range for such monitoring? Is it short wave, medium wave, or long wave infrared? The Mid-Infrared Alliance can count on top companies in this segment, like Xenix, New Imaging Technologies, High Specs, IR Nova, or New Infrared Technologies. And last but not least, real-time gas analysis also plays an important role for detecting unwanted vapors or even flammable compounds leaking onto the factory floor. Spectroscopy is the solution. I'm thinking of supercontinuum lasers from companies like NKT Photonics or Lucas, and quantum cascade lasers from companies like Nanoplus, Mirsense, Alplacer, or Quantium. If you match them with the mid-IR detectors from Vigo System, Enverium, or NLIR, you have a recipe for success. So do you manufacture mid-IR optics, filters, lasers, detectors, or cameras? Perhaps you integrate them into industrial manufacturing systems? Or do you want an independent reality check from end users? If so, then the Mid-IR Alliance is here for you. So if you are not on holidays on July 14th, or even if you are, take a break at 3 p.m. and join a great discussion. I promise you, it will be worth it. Magical things happen when we are tuned to the same wavelength, mid-infrared. Indeed, magical things happen when we are tuned to mid-infrared. Thank you very much. I see we are all here, Level Fluoren, Nanoplasm, LIR, NIT, Physics. I tried to mention as many of you as possible in this video. If I didn't mention any of you, just tell me and I will mention you in the next one. The most important thing here is to make sure that the story is cohesive, and it is. I'm extremely excited of what is happening here. Today, on the 14th of July, I can tell you that most of our staff is about to go on holidays, but we are still here working really hard and speaking on behalf of 15 people who dedicate their life to the photonic industry. It has been quite an amazing 1 year and a half that we had to switch to the online world, organize the best online events, but we also provide access to our network, investment, jobs in photonics, and lots of market reports. But you already know this because you are a big fan of EPIC. Thank you for being supporting us today. As I said already, is the last chapter of an amazing season 4 of online technology meetings. It's never the end because of your request, we are continuing on Q4. We are continuing with 1 meeting per week. I know many of you, including me, are going to be traveling in September on, but 1 meeting per week, every Monday at 3 o'clock. Mark it in your calendar. We have already selected the topics, and those topics are, of course, based on your input. And we'll continue also with the quantum technologies because you ask us and we deliver. We have 3 online quantum technology meetings. We're going to talk about atomic clocks, ion traps, and the big one, where the real money is, qubit generation. But today, on this beautiful 14th of July, I don't have a swimming pool next to me. On this beautiful 14th of July, we are talking about mid-infrared technologies for industrial manufacturing. And as I said before, this is in cooperation with the Mid-Infrared Alliance, the sustainable development of the pilot line MIRFAB to bring together every company in mid-infrared to make sure they find potential partners, customers, and suppliers, and they make sure that the mid-infrared is a sustainable European industry. Thank you very much, Photonics 21 and the European Commission for funding the developments, the funding of the Mid-Infrared Alliance. And also this meeting wouldn't be possible without the support of our sponsor today, coming all the way from Berlin, Art Photonics, the fiber optic manufacturer specializing almost every wavelength all the way to mid-infrared. So you're looking for a fiber supplier for the bad coupling of any laser diodes in the mid-infrared, for biosensors, for endoscopy. These guys have the solution. Art Photonics, thank you very much for sponsoring this event. And a person who had to delay the holidays for being here is Dr. Francesca Moglia. And for that, I'm eternally grateful. Francesca, what's in the menu today?
Thank you, Jose. So let's say I wanted also to delay the holiday, so Jose, but Jose was happy, yeah, it's true. So thanks a lot, Jose, for this introduction. So this is the slide we want to see. So not just the few speakers that maybe we'll have a few slides today, but also all of you that are here. And as you heard before, so this is the first, let's say, of the trips that we will take in with the mid-IR technologies. And so the application in industrial manufacturing, of course, implies, as you also heard from the video, a lot of things. So the end user first. So we know that there are different people that we were very well known that will have experience in this. So for example, additive manufacturing, but also our very famous LAMPAS project where we also build a workstation based on laser for surface structuring. But this is just the users, but then the technology, who brings it really? So lasers, of course. So laser technology, we see here, there is a big ecosystem, and we heard already from CO2, but also shorter wavelengths, a bit more challenging one, the new revolutionary one. So, and we are all, of course, supporting it with our Pulsate initiative for advanced and additive manufacturing services. So there we keep an eye on you as well for the mid-IR wavelengths, let's say. Then, of course, there is the big word of the hardcore photonics members in EPIC, and not only dealing with sensor and cameras. So in this environment and this wavelength range, you are many, you are interested, you are here, so we will hear your opinion, your challenges, what you propose to end users, and what you propose for solutions. And then, of course, the rest of the supply chain that is less important is there to support all of you. Filters and coating, the optics is also, there are challenges there in this wavelength range, not to underestimate. Optical fiber, but also all the materials that are needed. Metrology inspection is always important. System integrators that they can integrate cameras, but also other kind of systems. We will want to hear also from you your challenges and proposals. proposals, and not as the end as not important, but really always there, the R&D for the mid-IR technology of the future. And so let's now give back the word to Jose, because we want to talk to you.
Thank you very much. This slide only corresponds to the companies who registered for the meeting today. So if you're a company in the Mid-Infrared Alliance or in EPIC and you miss your logo there, you forgot to register. Don't let it happen again. All our events are listed in the website. Today we have fantastic 5 speakers. We selected these companies because of their potential to generate business to other companies. But in addition to these 5 companies, we have also other 10 companies, I think 12 companies, who are also going to present one slide about what they can do in the mid-infrared. This meeting is, of course, broadcasted in YouTube. So hello, YouTubers. If you want to get in touch with any of the participants today, send me an email, jose.pozo@epic-asoc.com, and I will make the introduction. Do it before Friday, because on Friday I'm going on holidays. Why don't we get the meeting started? It is time to start the first online technology meeting on mid-infrared. And for the first speaker on the first online technology meeting on mid-infrared, we wanted to select something that gave Francesca and me goosebumps the first time we heard the presentation. We bring them back because this company deserves that all the EPIC members help them to be even greater than already are. So all of you providing fibers, optics, packaging, assembly, end-user solution for femtosecond, listen carefully, because we go all the way to beautiful Canada. Louis-Rafaël, Femtum, femtoseconds at mid-infrared. Are you crazy? The floor and the attention of everyone goes to Canada, goes to Femtum.
Thank you very much, Jose, for this. We'll share my screen now. I think you should see the screen.
Yes.
Perfect. I will go in presentation mode. Well, thank you very much for this kind introduction. And today I will speak about Femtum. So Femtum, we are a mid-infrared fiber laser manufacturer, specialized in laser material processing of delicate, transparent, and organic materials. Let me start by giving you a small crash course on laser material processing. The goal is really simple, is to modify or remove materials with laser in a precise fashion. And you have 3 main parameters that you can play with a laser. Basically, you have to have the right wavelength, energy, power, and temporal regime of your laser. And this is a big claim, but basically what you need is the right short pulses at the right wavelength if you want to have high speed and high precision processes. And why do you need the right short pulses? Basically, in the worst case, you have CW laser, in which you melt the material. And the goal here with short pulses is to vaporize the material and not induce thermal effects. And when you are also at the right wavelength, what happens basically is if your material is transparent, it will just transmit the light through. It will not be absorbed by the material. So what you need, it's a material that is opaque to the laser wavelength. Having all this in mind, basically, if you have an application with a material and you're about to choose the right laser to do the job, then first thing first, look at the material absorption band, especially if it's a transparent, organic, or delicate material, and then choose the best performance to cost laser that fits your application. I plotted 2 examples here, water and 1 polymer high-density polyethylene, HDPE, and you clearly see that the highest absorption bands are located in the neighborhood of 3 micron in the mid-IR, and that's where basically you find the fundamental vibrational modes of water and hydrocarbons, so at 2.9 and 3.4 micron respectively. And you also see that there's other types of absorption, so in the UV or deeper in the mid-IR, so at 5 to 10 micron. Still, unfortunately, in the market right now, if you look at the laser industry, there are no real providers of mid-IR lasers in the 3 micron emitting short pulses. Right now, the most popular laser is the ytterbium fiber laser at 1 micron. You have to use femtosecond, high energy, very expensive lasers to process those materials. So the way people try to circumvent those lasers is going by excimer lasers or parametrically converted UV lasers. Those are complex to integrate. They are also dangerous. You can also use CO2 or CO lasers at 5 to 10 micron. The only problem with those guys is that they are not precise because of the wavelength, they have big spot sizes and they only can emit long pulses or CW light. So you have all these thermal regime effects. So basically, there's a lack of mid-IR 3 micron sources, and that's what we bring to the market. Femtum, we bring the first generation of short pulse fiber laser emitting directly on those resonances. We have two products right now, the Femtum Ultra Tune 3400 and the Femtum Nano 2800. The first one, it's a tunable femtosecond fiber laser between 2.8 and 3.4 micron. It's done very easily via software, it's done electronically. It emits very short pulses. And because of that, you can really target the maximum peaks. And for each individual polymers, you can target the maximum peaks. So that's why it works with almost all polymers. We have also a second laser, which is the Femtum Nano 2800. It's the 2.8 micron version emitting high energy nanosecond pulses. We have two versions, one that emits high energy pulses and another version that emits high power, so high repetition rate. In both cases, both lasers have single mode fiber delivery. It comes into a rack mount 19-inch and they are air cooled. They are very easy to integrate into a machine and to make your application as easy as possible. So what can you do with those lasers? Basically, you can enable new capabilities in polymer processing. You can either start with doing macro bumping, macro texturing. You can also change the refractive index of the polymer, so to make light circuits at the surface. So you can inscribe basically waveguides. And finally, you can also ablate the material. So then there's a lot of application on ablation, like marking, cutting, things like that. And in this case, some polymers, actually, we can decrease the damage threshold by a factor of 200x when you're at the right wavelength. So let's say for high density polyethylene, it's very high, the damage threshold. And for us, it's like very, very low because just of the wavelength and the high absorption. Another set of application, and thanks, Jose, for giving a nice talk earlier about this. We can do selective laser processing. And basically for thin film patterning, it happens that a lot of thin films has very strong absorption bands in the mid-IR. And we can really selectively ablate one layer on top of the other without fragilizing here the PET substrate, the glass substrate, the silicon substrate. We have done gold on glass as well. So metallic thin film can be patterned as well. And there's another set of application in which we try to strip polymers on metal, so for wire stripping, and also polymer on glass stripping. And in this case, we have basically developed this process, and it's pretty difficult to find the right wavelength, right laser to do the job because both materials are transparent in optical fibers. And basically what we can do at Femtum is provide you the right laser to do this job very efficiently and precisely. So to conclude, if you're limited with your processing application today, you have something you want to do, we have equipped ourselves at Femtum with an application lab. So basically we can pattern and try out our lasers on your samples. So what you can do is send us your sample. We can make a demo. And to do this, go to femtum.com or contact me directly via LinkedIn. It will be my pleasure to assist you. Thank you very much for your time.
Thanks a lot, Louis-Rafaël. Now it's, there is the heavy question that you were missing. So I will ask you. So I'm proud of it. Sometimes people don't put it in the slide, but they say it at the end. So you didn't. So what can you do for them and what can they do for you? So do you have some challenges for all this fantastic audience? They could be integrators, they could be your supply chain, they could be towards application. What is in your mind that the mid-IR expert can help you with?
Yeah, sure. I would say that these wavelength, generally speaking, so what people can do for us, 2.8 to 2.4 micron, it's not a typical wavelength, and everything right now is quite expensive, or it's hard to produce the thin films and things like that. So new optics, like high power optics that can tolerate, high power, high energy pulses in those wavelengths. This is always very good. And what we can do to people, basically, we can provide them new generation of lasers for developing new laser process.
Very good. So then we have here someone from the supply chain who maybe wants to talk, because otherwise, talking about fibers, of course, Art Photonics comes to my mind, and so Slava can tell us a bit what the monstrous expertise there. Slava, are you there?
Yeah, I just have one question. Very good.
Yes, if you have a question, even better.
No, it's nice question. When you do some kind of, let's say, stripping of polymer from fibers or from the metal, I think for any process, especially when it's laser, let's say welding, laser ablation, what else, it's good to have a temperature monitoring. How you manage for your end users this process? Because you can adjust it, of course, by your parameters, but maybe the best way will be to have inline temperature monitoring non-contact, which will simply provide to the customer exact energy, coming for the precise thickness of ablation or what else, or welding, because for polymers, of course, it's very important to be in green corridor of temperatures. Because we simply do this kind of fiber optic, how to say, pyrometry, which can simply control exactly in the point of illumination.
Yeah, it's an excellent question. Actually, so we are a mid-infrared fiber laser manufacturer, not the laser machine integrator. So let's say that would be the job of the integrator to really put all together all the components, subsystems like cameras and optical fibers to make the system. We do proof of concept jobs in-house, but the goal is just to sell the lasers, to machine builders, and then they will provide the solution to the end user. So we are more like a laser provider than a machine laser provider.
But I think if it will be so-called smart laser, like let's say something which will provide better parameters to the end user, then you will get a better sale.
It's a good point.
Don't limit yourself. You can do more, or we can do more together.
Sure.
I would follow the suggestion of Slava. Slava knows always. Talk to him, even if
not always.
Not always, but this time sounds an interesting suggestion. But Slava, do you want to maybe tell us a bit more of your expertise as well in art photonics? Maybe with one slide. You have it if you want it.
Give me a chance, for one slide. Can I share my screen?
Sure, you can. Go ahead.
Okay. Now you see the slide?
We do, yes. It's not presentation mode, but if it's easier for you, we see it very well anyway.
Yeah, I can do it.
Perfect. Very good. Thank you.
Okay, we are simply involved, and I already mentioned to Louis that in general, for example, infrared imaging can be provided from the zone of illumination. So that's why it's great to have fiber laser, which let's say provides radiation at 2-3 microns. But flexible delivery of other lasers, CO, CO2, is also possible. What we can provide, hollow waveguides or other fibers. This is carbon dioxide, this is carbon monoxide lasers. That's why I can only mention that for every participant of this meeting. Just keep in mind, any process needs control. So that's why if you do laser welding or what else, you need maybe temperature monitoring. It can be done in non-contact mode with a flexible fiber. If there is flexible delivery for lasers where there are in the moment no fiber lasers yet, there are some super continuum, but it's kind of exotic in the moment, chalcogenide. And that's why here we also, for the process, in chemistry, in industry, petrochemical, food industry, what else, we always provide also a chance to control what's going on in your soup. So if you are doing chemical reaction, you can monitor how the components are changed, and it's done with fiber optic probes. So that's why we are happy to suggest all participants of the meeting flexible delivery in mid-infrared. And we do have also excellent partnership with LWIR for the range of, let's say, shorter wavelengths. It's not here, but 2 to 4, maybe 2 to 5 microns. But we have right now with them fluoride, chalcogenide, polycrystalline, and hollow waveguides. Anything flexible you need for this range is available. So that's why welcome to take ours and provide, how to say, better process to end user. That's it.
Thank you very much. And I think there is obviously some room for cooperation here with Femtum. And later you're going to hear what the amazing job that LWIR is doing with Louis-Philippe, which is a success story of Europe. Thank you very much for being with us. I'm going to go back to Louis-Rafaël. I love your technology. As I showed in my video, you are one of the rising stars in this network. I want to find you more cooperations. One thing that we had discussed offline has been the filters for mid-infrared. Is there any challenges there? Any room for cooperation? Any item in your Santa Claus Christmas list in July?
Yeah, and filters actually. So the higher the transmission, the highest power they can tolerate, the better it is for us. So we have some like there's many applications when people want to use our lasers. Long passes, a lot of things that can be done with let's say filters for sure.
I have a couple of companies here who I want you to cooperate with. I'm going to go first to Sweden and then back to Canada. First, I'm going to go to Sweden because there's a company here, Spectrolytic, which is one of the key companies in EPIC developing thin film-based filters. Thank you very much, Costas, for being with us this beautiful afternoon. Costas, could you tell me a bit of what do you do for mid-infrared filters that could be helpful for Femtum? Tell me, I know you have one slide, and let's see if we can find some cooperation. Costas, you are muted, and I have a mug somewhere to celebrate that accomplishment.
Yes, there we are. Actually, we don't develop filters as such. We develop various spectrometer solutions, either with discrete channels or continuous spectrometer solutions. So we are largely on the other side. We are in the integration side of the spectrum, so integrating components to create measurement solutions rather than filters themselves. So in terms of the actual just filters, I don't think we'll be able to be of any particular help, but for various applications, we might be interested in integrating a laser.
Costas, normally I will get out of this line, but I'm going to tell the truth. In my mind, I had a spectrogon and not a spectrolytic.
Right.
I made a mistake with that, so I am very sorry for that. But it's you develop spectrometers in the mid-infrared. I'm going to come back to you later because we're going to make a round about this. But I'm going to go to Iridian. Do we have Iridian with that? Jason Palidwar. Good afternoon for me. Good morning for you. Can you tell me about what challenges there are in the mid-infrared filters and what kind of cooperation we could start with Femtum?
Yeah, sure. Certainly, we're very active in the mid up into the long wave infrared with optical filters. Well, actually, always all the way from the visible all the way into the 15 micron wavelength range. Different materials for our optical coatings. So the challenges from a filter manufacturer perspective is working with different materials and the reliability, robustness of those coatings and creating the performance needed. But customizations, what we're all about. I've got a screen I can share if you'd like. Jose.
Yes, please. And remember that his challenge is on power. He's worried about the amount of power that goes through the coating. Yeah,
that's always it's whether it's a challenge for us or not. It's challenging to know if it's a challenge. We don't have a lot of experience with testing of each individual filter type in the different laser damage thresholds. In the visible, the materials who work in that range, you're looking at surviving up to sort of a megawatt per square centimeter type of range. So I expect that things would likely be okay in the midwave IR, but we'd have to work together and test that. Certainly, we're able to customize bandpass filters as I'm showing here, but long pass, short pass, edge, notch filters, custom filter designs in the midwave IR is certainly one of our offerings, and be really interested to hear what you're interested in and really what you're looking for in terms of how much power and what's the laser damage threshold that you're concerned about. Maybe it's not a concern for us, so be really interested to talk more.
Actually, there is a question for you coming from Simon, also from Femtum. Simon, unmute and ask the question. Ask away.
Hello, guys. Thanks, Jose. So yeah, we're also interested in filters in general. So short band pass filters with a very, very small bandwidth. So is it something that you can provide also?
What do you think small is?
Like bandwidth below 10 nanometers or 5 nanometers?
That's certainly possible in it scales with wavelengths. 5 and 10 nanometer bandwidth filters are regular, easy processes for us in the upper end of the UV, visible, near infrared. Those are very standard run-of-the-mill filters. As you get farther out in the long wave IR, that gets more and more challenging. You're looking at something more like on the order of maybe a percent of the center wavelength. So if you're working at three microns, something like a 30 nanometer wide filter would be on the challenging side of things. Okay. But we're happy to look at it for you.
Jason, you develop coatings that go all the way to the 10 micrometers, and you have to pay attention to the next presentation. It's about CO2 lasers. Pay attention to that one. Before that, my friend Rudiger is on the room. And when Rudiger is in the room, RP Photonics is in the room, I need to tell him, say something to the public. Rudiger, good afternoon.
Yeah, hello, nice to be here. First, a short question. What kind of lasers are these? Are these erbium-doped fluoride fiber amplifiers?
Yes, sure. Yeah, we have, let's say, yeah, it's based on erbium, yeah.
Okay. Is there any interest in modeling in this area?
I would let Simon, if Simon, I don't think so. We have our own simulators in-house, but it could be for very advanced physics, not really for our own purpose.
Yeah, just to let you know, I have very advanced simulation and design software, which is also very good for these special systems. You know, these erbium long wavelengths are not so easy to model as ordinary 1.5 micrometer devices. And I have very advanced software. You can have your even user-defined level schemes with all the transitions and everything that could be useful for the optimization in some cases. Just come back to me if you're interested.
And you also had the most important catalog in the history of photonics, rp-photonics.com. Thank you, Rudiger, for being part of this network. Are you ready for CO2 lasers, Rudiger? Because I can't wait anymore. I'm going to the mid-infrared laser source by definition, the CO2 lasers of Luxinar. Gavin Markley, he is the technology stream manager. This is the coolest job description, technology stream manager at Luxinar. The floor and the attention of everyone goes to CO2.
Right, hi guys. I'll try and share, if I may. Okay, I hope you guys are seeing that.
Not yet. I think when you click on share the screen, you also have to select which screen you want to share with the world.
Okay, joy.
I got all the public excited about CO2 lasers just for you.
Unfortunately, it's not sharing, and I think it's because I have two screens and I can't.
Yeah, just select the one. You will see.
Yeah, I'm trying. No, I'm unable to share. Can you unshare me again, please?
There's nothing to unshare, but what you know, I had the people from Guchan Hausko, Stratos here. He's the CTO of Guchan Hausko. We want to understand a little bit more how we can do the photonic components Guchan Hausko can improve Luxinar. So we are all super excited about this, Gavin. Can we? Do you want me to come back to you? No, yes, you are in business. You make fantastic CO2 lasers. You can share the screen, had no doubt. Okay. You are sharing with us the Epic website, which is fantastic, but we want to see your PowerPoint.
Okay, hang on. Bear with me a second. All right. Come on. Where are you, my dear?
Stratos, after the presentation from Gavin, I'm going to come back to you so we can have a quick of a debate about what kind of photonic solutions are needed in the CO2 and femtosecond lasers that we've seen so far.
Sure thing.
I love Guchan Hausko. I'm so happy that they are part of this fantastic network. And Luxinar is ready to start. The floor and the attention of everyone goes to you.
Okay, can you see anything yet?
Crystal clear.
How about
that? Before we're crystal clear, now we are not. So you're sharing, go to display settings there in the screen that you're sharing with us. Go to display settings or that. All right, so we are in business almost. Go to display settings. Gavin. All right, so can you click on presentation mode?
Yeah, apologize for this, guys. I'm not having a great day.
Don't apologize. You are doing a fantastic job.
Yeah, really? Okay, hang on.
Let's see how we can solve this out. I think you need to click on slideshow mode.
Hang on. Screen 2. Does that share?
You are now, well, now it's good. Start. The presentation is fantastic. We see it Gorilla Glass clear. The floor is yours.
Okay, that's great, but I can't see it. I don't think I can change anything. Hang on, let's try this.
Press the space bar. We'll go to the next slide. You know what I'm going to do? My team is going to call you on the phone and it's going to give you a crash course on how to share the screen in Zoom. And then we'll go back to you. And in the meantime, we're going to go to one of the presentations that we all were waiting for. We're going to go to Italy. because just won a tournament in football, I heard, but we're not going to talk about football. We're going to talk about Prima Industries. The R&D manager of additive manufacturing, Erika Librera, is here with us to talk about their challenges on mid-infrared. This is the presentation you all have been waiting for. Erika, grazie mille for being with us. Congratulations on the tournament. The floor is yours.
Thank you. Hi to everyone.
Hi.
Share my screen. Okay, probably now
Yes.
you're
Perfect.
You're looking at the presentation. I'm Erika Librera. I'm in the group of R&D of Prima Additive, and I am the responsible for the laser metal deposition systems. Some words about Prima. Prima Additive has been born in 2018 from the Prima Industrie group. Prima Industrie is a leader market in the metal sheet manufacturing, but Prima Additive is focalized on the additive manufacturing processes, and in particular, in Prima Additive, we are studying and we are developing the two relevant technologies for the laser additive manufacturing, the powder bed fusion system and the laser metal deposition technologies. Both the technologies are based on the interaction between the laser beam and the powder. In the first case, the laser is focalized and moved by a laser scanner, and the powder is disposed on a bed, and it is fixed, it is not in motion. With the movement of the laser, we are able to melt some parts, some points and areas in order to define a precise geometry. The movement of the platform on which is located the powder bed allows to generate a three-dimensional part. In the case of a laser metal system, the situation is different because the powder is in motion, is sprayed from a nozzle tip thanks to the help of a carrier gas, an inert gas. And the laser is coaxial with the powder flow, is focalized on the same point of the powder. The powder also has a focal point, a circular geometry. The movement of the heads and the nozzle tips allow to the generation of three-dimensional geometries. This kind of approach is particularly indicated for repairing application, recoating and repairing or remelting of pre-existing surfaces. The powder bed instead is optimal for the generation of free structures for the aeronautical sector, for biomedical sector, many different industrial applications. At the moment, we are looking for monitoring system that is an important aspect for the additive technologies. It's a central point in additive. Prima is integrating a commercial product, the LWIR monitoring system from NIT. It is a camera, an infrared camera that is located coaxially with the process. It is able to see, detect, to collect the information coming from the melt pool directly from the process. It detects the dimension and the shapes of the melt pool during the entire evolution of the process. The camera is also, the system is always able to collect the information, but also to act directly on the process because it works in closed loop control on the laser power. This kind of system is particularly indicated for very long process in which we have the remelting many times of the deposit layer. At the same time, it's very useful in case of critical features like corners, sharp edges, or curvatures that generate instability in the process. This is the example reported in the slide in which an empty wall, an empty cube, is deposited by a series of thin walls. What we can see is that without LWIR, the deposition is not flat, and we have a sort of overbuilding on the corners. The corners are a critical point because the process is changing direction and at the same time is decreasing the speed. These generate a sort of instability in the melt pool. With the help of LWIR, we are able to correct this effect, to modulate the laser power in order to maintain constant and stable the process. And at the end, we obtain a flat geometry. But we are studying a lot around the monitoring system because we want to integrate more and also to understand more the information coming from the process. In particular, we are looking for higher resolution camera in order to collect more information and to be able to depose more precise geometry than smallest feature. But then at the same time, we are looking for something different. For example, a sort of visible system or camera or something that is able to maintain fixed the distance between the nozzle tip and the deposit part. The standoff distance is a critical point in the laser metal deposition technology because it generates a sort of instability in the process. One of the most common problems is the presence of underbuilding and overbuilding during the deposition, like in the case of the corners in the square. And another important aspect is the integration of some sensors inside the process, inside the camera, the working area, because we can in some way detect the fume or all the products that are generated by the fusion of the metals. And probably in this way, we could be able to detect the quality of the fusion of the process during the deposition. All these applications are related to the laser metal deposition systems. At the moment, we are not integrating something on the powder bed. And we want to increase this aspect because it is important also for the powder bed to control and to check the quality of the process. Probably critical aspect is the presence of the laser scanner, that is an optical element inserted inside the optical channel, or the optical chain, and is not in some way limits the possibility to collect information directly coaxially by the process. And we are looking for something also in this technology. Thank you.
Thank you very much, Erika. Of course, I couldn't find to unmute myself. Thanks a lot. So thanks a lot also for your perfect setting on the epic question. So it's clear that we throw in the room a big stone because we know there is Rodrigo here that is helping you already. And we talk to him maybe later, right after your talk. But who else can think about helping Erika here? So with cameras, but also sensors you saw, also with the power bed fusion, maybe there is really the full world is still open. So if you're not convinced yet and you don't want to raise your hand, I will ask another. We are in a additive manufacturing business. So I think it's time maybe to ask Martina from BEAMIT. Welcome, Martina. What is your opinion about the technology? What is MWIR can do also from your perspective?
Thank you, Francesca, for the introduction. Hello, everybody. I also have some slides, so I can just give you
some slides. Dangerous.
One slide. Sorry.
No problem. Yeah, if you can share your screen, we see it.
Yeah, can you see
it? For me, yeah, it's there. Go ahead.
Okay. Yeah, so just to introduce to all of you with BEAMIT. BEAMIT is one of the solution providers for additive manufacturing. We are producing components in additive manufacturing, especially in laser powder bed fusion process, so the one that Erika just explained before. And we are producing these metal components for high demanding industries. We believe that online monitoring is very important and very interesting for this kind of process, because especially because the complex geometries and the lot sizes of the additive manufacturing are not very suitable for the standard quality controls plans and techniques. So that's why the online monitoring can be the solution in order to achieve the quality assurance of the process. So we know that, I mean, there are a lot of literature works on thermal monitoring with this photo-bed fusion process. So it is well known that it is possible to detect the effect, the process-related defect with photodiodes or visible or infrared cameras, but also mid-infrared cameras. But all these solutions are very used in R&D application, and no of them is used and is really applicable in the industrial environment. And for us, the main critical aspect of this application are the fact that each machine supplier is developing and integrating on the machine its own solution, so its own sensors and monitoring system. So the standardization is difficult, and when it comes to high demanding industries, the standardization for production is very important. Then the online data analysis and the closed loop control with laser powder fusion is very challenging because of the huge amount of data that is collected with this 3D printing, 3D process, and also the sensors are quite expensive. So yes, the question and the answer. So what can you do for us? What we are looking for is someone that can develop a sensor and its monitoring system that can be easily integrated in different bed fusion machines. So that can be machine agnostic, so we can integrate it in all our machines. And what we can do for you is, of course, to drive the end user needs and experience and collaborate on the development of the process, and of course give the access to all our machines because we have different models and machine suppliers in-house. So, yeah.
Thanks a lot, Martina. That was really, really useful and really epic targeting. So thanks a lot. So now we have it. This is the additive manufacturing block today. We have Eric and Martina. So this is your time, and I see that you are getting awake, kind of. So it's time for JJ to ask his question from Vigo. JJ, ask your question to Erica. I guess it's more affected, but maybe Martina is interested as well.
Thank you very much. And the question I wanted to ask him, Erica, you mentioned that you are in need of a sensor which can detect some fumes during your processes. So what kind of fumes these are exactly, and which are the concentrations we are talking about? Because I understand that the scale in which of the place in which they need to be detected is relatively small. But what kind of fumes are these? Because I'm not an expert. I do not even know very much about additive manufacturing. So I wanted to know simply what kind of substances we are talking about here.
Okay, hi. I'm not an expert about the fume that can be generated during the process, but usually what we see during the deposition is that in some cases, due to the oxidation or the presence of oxygen, we have the generation of some element that in some way worsens the quality of the deposit part. This is a possibility, this is a question, could be a solution to be able to detect this kind of fume, of this kind of product due to the reaction and the fusion of the metal in order to prevent damages or the abort of the work, of the job of the deposition. Probably we can talk about that because we are working with different materials, and especially with the steels we have, or with the titanium, we have the production of fumes. And we can check with you, and also with my team in order to answer correctly to your answer.
Right.
Question.
I was just interested because especially if it's some gaseous materials, so some gases to detect, we can discuss this. So I'll just leave some contact info and we can discuss this, in a smaller circle, so to say, because this is a quite specific question from my side. I know that.
Good, sounds like a plan. But maybe JJ, you maybe want to say a couple of words more about Vigo expertise. Maybe you have a slide or two.
Yes, sure. I have a slide, so I will share
Very
it
good.
quickly.
One slide, you see, you even corrected me.
is.
That's the right attitude.
Yes, it is one slide, and I think that you can see it now.
We
So
do.
so yes, first of all, we I think that most of you know that we manufacture infrared detectors. Currently, not only with MCT material, but also the 3.5 based materials, so ROSE compliant, indium arsenide, antimonide, and so on. We are currently focusing more on the whole detection modules, so also supplying electronics to the detectors with possible analog and digital outputs. Some miniaturized custom solutions are also possible. The epitaxial wafers is also something that we can do for you if you are a manufacturer of some sophisticated electronics like lasers, transistors, and so on. The list can go on, of course. What we do for industry is, as I said, the gas analysis. We are able to supply detectors, detection modules, and even cooperate on the whole solutions for gas analysis. Which is also a key of the mid-infrared spectroscopy, which can be done in industry for ambient air analysis and so on. Laser power control and calibration, we also do that, as our detectors cover most of the mid-infrared spectrum and most of the common laser lines, including the QCLs. Temperature control is also something that we do. We have more expertise in railway industry, but in manufacturing industry, the principles stay the same. The black body curves are the same anyway. So and what we intend to do is to cooperate on optimal integration in your industrial systems to miniaturize the whole sensors, to develop the whole sensors for you for specific applications, but also you can do something for us. As I said, the most valuable things you can do to us, you can do for us, is to give us ideas, is to give us applications on what to do, in which direction we should go. What do you want our detector systems to do? We are eager to...
Jerzy, you are one of the success stories. Vigo is one of the success stories of Europe, and helping Vigo is helping Europe. So I would really recommend anyone to really collaborate with this company that goes from the material growth all the way to developing some of the most used in different application fields mid-infrared detectors. Yeah, dziękuję bardzo. But I'm gonna go back now to Prima Additive. The reason why I want to go to Prima Additive is because you talk very clearly about the need for the monitoring on the additive manufacturing. You talk about a higher resolution camera, and I would like to dig a little bit into this. What is, in your opinion, the main well, you could share with us some numbers about the resolution that you need. 200 kilohertz, what you said. Martina, are you with us still?
Yes, I'm here.
Erika, sorry. The both superhero superstar today. Erika, you talk about 200 kilohertz infrared camera that is needed. I wonder if you could share with us some more specifications on some more items in the Santa Claus Christmas list, such as the wavelength, and also if the application is purely for metal or you're considering other materials as well.
No, for us, it's interesting only the metals, because in both cases, with the powder bed and the laser metal deposition, we work always with metals. And at the moment, we want to see a higher resolution of the borders of the melt pool. For this reason, we are looking for a higher resolution camera.
What is the wavelength range that you typically use for this kind of monitoring? Are we talking about short wave, mid wave, or long wave infrared?
No, sorry.
Hold on the answer, Erika, because there's a person in the room who has the answer. I'm gonna go all the way from Italy to Spain. I'm going to Madrid because Rodrigo Linares from NIT is here with us. Rodrigo, when I ask you which wavelength, you're going to tell me mid-wave infrared. I know that, that's okay, but I want you to tell us how and why. And afterwards, I want to have a discussion because there's many people who, in my opinion, can help and also, in my opinion, can really benefit by fully understand the huge boom, which is mid-wave infrared for detection monitoring. The floor es para ti, Rodrigo.
Muchas gracias, Jose. Thank you very much, and well, welcome to everybody. Let me share my screen.
I always let you.
Okay, I guess that now you can see my my screen. Well, indeed, for all of those that don't know us, we are a Spanish company called Infrared Technologies. We are a vertically integrated company that supplies very innovative mid-infrared detectors, cameras, and industrial solutions, which our focus is to develop and offer to the industry solutions for real-time process monitoring and smart control of the processes. I have already heard in some of the people talking before about these needs of process control and real-time process monitoring, and that's where we are focused to. So all our solutions that we offer, they are based in self-produced infrared cameras, which are manufactured with a unique proprietary technology. And of course, these are the key points of our technology. To answer your question, Jose, before, we have sensors that are sensitive in the mid-infrared band, but detection from 1 to 5 microns. This is a key point when you want to monitor a laser-based process, especially if you want to do an on-axis or coaxial monitoring. They have high capabilities, high-speed capabilities, and uncooled operation at room temperature. These 3 points, which the main derivative is the low cost or affordable solutions, are key for introduction of this technology into the production line. I think detection in this wavelength band, high speed and uncooled operation, affordable solutions, key points for the introduction of this kind of technology in the production line. We are now also producing thermal and cooled cameras sensitive in the long wavelength infrared band from 8 to 14 microns. This is just a summary of all the products that we offer to the industry. What we can offer to the industry, we have sensors of single pixel or linear arrays. We have a high-speed and cooled camera called Tachyon 16K Camera Plus. This is a state-of-the-art in this kind of technology. It's a camera that is capable to operate at 4,000 frames per second. It's a camera that operates in snapshot acquisition, meaning that all the pixels are acquired at the same time. And this provides significant advantages compared to other technologies because you can see clear images of high dynamic processes like laser ones. The camera is compliant with GigiVision and GeniCam, so it's ready to be installed in the production line, and it's powered over the Ethernet. So it fulfills most of the industrial requirements of our customers. We also have solutions like CLAMIR and i3MS. I think CLAMIR, thanks to Erika for all the introduction that she did before, this is a solution that we offer for the quality assurance of laser-directed energy deposition 3D metal printing. It allows to perform a closed-loop control of the laser power. This is important. The system is embedded, meaning that the system is performing a real-time monitoring of the melt pool width in this case and provides the control without the need of connection to the computer. The system can work by itself. And it also important, it allows a direct integration in the laser optics, meaning that it provides a coaxial observation of the melt pool, and based on that information is providing the process control. We also have now a thermal camera called LIR 320, which provides thermal measurements. It's very compact, and the communications impoverished through the USB. So it would allow to monitor other kind of process results. in this kind of industrial manufacturing processes. Just a few words about CLAMIR, which was mentioned before by Erika, and also in BEAMIT, when the person from BEAMIT mentioned before that there was a need of sensors for online monitoring. This is the kind of applications that we are focused to. So we have a system that provides a continuous closed-loop control of the laser power, avoiding the overheating of the part that is manufactured. In this case, it's 3D printing using laser metal deposition. This allows continuous and high-quality manufacturing process and reduce the rates of defective part, material use, and energy than uncontrolled process, helping to optimize the productivity. It's also compatible with ELA, which is a high-speed process now used in many industries for laser cladding. Here you can see an example of the kind of information or the kind of data that you can get with this sensor. On the left, you can see a part that is being built with CLAMIR control. You can see that the aspect of the part is quite homogeneous and similar to what Erika showed before. And on the bottom part, you can see the homogeneity when building the part. On the right side, you can see what happens when you don't do process control. And I also take the words from Slava before that every process needs control. We fully agree with that. We know that an industrial process needs process control. And of course, there are many applications in multiple industries, automotive, aerospace, steel, for example. The focus, the applications where we are focused are the quality assurance of laser-based process. I presented CLAMIR, but we also have solutions for laser welding, combined with real-time machine learning processing, so with artificial intelligence, SLM process or powder bed fusion, where we have the camera that is capable to monitor coaxially the process. Here you can see a small video of a melt pool monitor on axis with in a PBF machine. So this is maybe interesting for Erika. And we have also tested the concept of CLAMIR in hardening and in hardening process, and also in surface structuring using the camera with in the project Lampas that we collaborate with EPIC. But there are so many other applications that are listed here, like for example, arc welding or wire arc additive manufacturing process monitoring and control, glass manufacturing quality control, spectroscopy, etc. So this is what we offer to the industry: high-speed, real-time monitoring and control solutions, affordable solutions. And what do we need from the industry? I think that we need that the industry moves or adopts the machine vision concept, but based in infrared, not only invisible, but also moving into the infrared. I think that's important for process monitoring and control, as the integrators or the solution developers to adopt this technology to develop more control and quality solutions. I think that's the message that I want to leave with my presentation.
Thanks a lot, Rodrigo. So this was a bit of a success story. So where we can start from. So we heard NEAT can already provide these cameras. If there is someone that they can also offer like a more higher resolution, we will see. And also we can contact Erika afterwards. The data handling is an issue for Martina as well. But I would suggest also Martina to talk with NEAT, and that's a good start. And Rodrigo, I guess we have a question for you in the chat. So from Lambda X, so please, you can speak up, Philippe.
Okay, I have just a simple question, because from one of your first slides, I'll start my video. Better
very
like
good,
that?
we see you now. Yes,
yeah,
thank you.
So very simple question from one of your first slides. It seems that there is a gap between 5 and 8 microns, where there is no camera. Is there a limitation there to explain this, or is it?
Mainly it's because there is a low transmission because of the atmosphere absorption in this wavelength range, especially from between 5.5, 6 microns to 7 microns. And that's why there are no sensors there, because there is no transmission of the infrared signal in those wavelength ranges, mainly. Usually,
okay, because of water vapor or something like that?
Yeah, mainly related with water vapor.
Okay, because there are some relevant wavelengths or spectral lines for spectroscopy in this range.
You have, in that case, our sensors, they can reach 5 microns. I know that there are other sensors in the mid-IR that can reach 5.5 microns. And then on the other side, you have thermal cameras starting detection in 7 microns. But I agree there is a gap between 5.5 and 7 microns where there are no sensors available, mainly because there is no transmission in the atmosphere.
Okay, thank you.
Eric, now there is a question. You have the virtual hand on. You can ask your question, please.
Actually, it's not a question. It's just to answer to NIT to Rodrigo. There is no fatality for. I will present myself later. But there is no fatality for the infrared detector in this range from 5 to 8. It does exist technology and company that could customize the detector for you. But actually, as there is for military application, effectively in the 5 to 8 micron, there is no transmission, so there is no high volume currently production for that. But if your business case is interesting, definitely we could design and customize a detector in this range, no problem.
Yeah, Eric, and then you can also maybe talking about business. Maybe you can talk a bit more about your business in IRNOVA, right? If you have a slide to want to show, now that you have the microphone on, let's take advantage of this.
Yeah, I need to share my screen.
Yes, down the bottom. Let's see. Yeah, something is coming.
I know. I don't need usually to have.
Yeah, careful. We see your slide, your emails now. Change the screen.
Thanks,
yeah, there we are.
Thank you so much. So 2 slides, one to present, to introduce. With my French accent, I'm, however, working for Sweden. So I'm in Sweden currently working for IRNOVA. And IRNOVA is supplying infrared detector for very high-end application, very high sensitivity detector. So not the kind of detector that NIT was looking for, because they are quite expensive, I would say, but not that much. We could also make the camera more simple at the end. And so just this slide. So I focus this slide, my sole slide, this one, on the mid-wave infrared detector, because mid-IR, it's in the mind of Jose, it's from 2.5 to 15 micron, but in the imagery work for detector, it's mid-IR, it's from 3 to 5 microns. So that's I was a little bit confused on this. So we have technology where we can customize definitely the cutoff wavelength, the spectral range for different type of application. And we can also, with this technology, we can also provide very high, sensitive detector in a very small volume. So if you compare to microbolometer at NIT, definitely this is not a low volume, but for this type of application, for high-end application, this is the smallest detector that you can find out of US for the full midwave 3 to 5 range. We developed this technology, and this technology, we have also the possibility to customize definitely the spectral range. So of course, currently, we are addressing the mainstream business, that means the 3 to 5 regime. But for gas application, notably, we are currently customizing gas detection application. We are customizing the cutoff wavelengths, and we can also customize the filter at the pixel levels. As you can see here, we can also at the pixel level set some filter. For this, we were using we were dealing with a Swedish company. I think that I saw Spectrogon to attend this workshop. So we did a very we are doing these kind of things, and we can customize the filter to the wavelengths you wish in the 3 to 5 micron range. So that's something that we have specific at IRNOVA, and I would say unique out of US. And we can also customize the filter, not only, of course, at the pixel, but we can customize the filter into a very narrow filter or specific band filter for the full array, for the full detector. I hope I was not too long.
Oh, that's good. He was connected to the question, so you brought it very well in. So thanks a lot for showing us your slides. Thanks a lot. So now Rodrigo also got his comments, so that's a good point to start with. And now I would like to introduce you to some new friend we have today. Adrian, you are in the room, right? from Aerospace.
Yes, I'm right here.
Yeah, there you are. So welcome to our welcome to one of our meetings. So I hope you are enjoying it, and maybe you can tell us a bit what is your company doing and what are your interests here, so that we know you and our members can keep your name in mind, maybe.
Sure. Thank you very much. So thank you for hosting a wonderful meeting. It's about 7 a.m. here on the West Coast of the US, and it's been pretty easy to wake up. There's a lot of great energy. A little bit about me. My background is in material science and engineering. Previously in the semiconductor industry. Now I'm at a company called Varda Space Industries, and we're working on building up orbital manufacturing capability. So in about 18 months, we'll launch our first satellite, and the goal is to be able to process materials in an environment where you can control the kinetics of phase changes a little bit better. And so the early application we're looking at is producing some of the fluoride fibers for these mid-IR applications on that satellite. And I've had a chance to meet a few of the folks on this conference. It's great to see them again. And really what we're looking to do is provide the ability to make better glasses in that environment. And then kind of what we need is to understand better what are the specifications that are need to be hit for the different applications. And then we're also interested in working with folks on solving some of the challenges related to material quality that are independent of the kinetics. So things like impurities, how do you make better glass, raw materials, those types of things. And we're about 15 people. The company's about 6 months old. And as the company grows and progresses, we'll be able to demonstrate more and more of our capability. And we're very open to figuring out how to help this industry grow faster, whether it's the manufacturing capability or in some other way.
Thanks a lot, Adrian. Awesome. So you didn't know the rules and you entered already very dynamically, despite the 6 a.m. that you started with. So I'm very proud of you. Thanks a lot for introducing yourself and also Aerospace. So I guess there is some room of cooperation. I know you know some of us already in EPIC, so that's very good. Let's keep Adrian's name in mind for those who don't know him yet, and that's a good opportunity. So now I would like to go back to some of the questions that we have still for Femtum that were not answered, and maybe we can also involve some of you more. So we have talked now a lot of metal, so with our 3D printing experts, but now actually Louis-Rafaël was the one talking about more non-metal processing with these lasers. So first I would like to ask from CSIR, we had a question. I know maybe you discussed already offline, but it's good to make it loud for everybody. So Charles from CSIR, are you there?
Yes.
Yes, there you are. So if you can tell a bit what was your question to Louis-Rafaël, so that we know this is something cool, and it is, I know, because I read the question. So you can ask it so that everybody knows, and also on YouTube hear what is your proposal, let's see.
So I've just had a question on if they've got a requirement for higher energies at mid-infrared wavelengths. So we've developed ZGP technologies that will be able to amplify that specific laser power and laser energies. So if they've got a client that wants to buy it but is not sure about the energies that they can reach, then we'll be able to help.
That's very good to know. And ZGP is for sure a complementary technology and for scaling up, especially in the long wavelength range. It's a very good crystal, and there's a lot of hype around this crystal. So I'm glad that you reached out today to us.
And I'm glad that he did, because as I said, anybody helping Femtum is helping the innovation in femtosecond lasers for the mid-infrared, and that's very important, Louis-Rafaël. But now we're going to do an exercise, which is super cool. I'm going to take a laser, semiconductor laser, a detector, and a coating, and we're going to make a system with this. We're going to understand the challenges on building a system in mid-infrared. The laser is going to come from one of the key companies in the world providing a semiconductor laser for every wavelength. We go to Nanoplus. Lars, good afternoon, all the way from Würzburg in Germany. Tell us what you do, and I'm going to find you partners afterwards.
Yeah, hello, Jose and everybody. Thanks for giving me the opportunity to show one slide. I think I'm the only one maybe who has only one slide. Everybody else has 2 or 3 slides. So next time I'm going to have some more. We're in this field of the mid-infrared quite some time doing semiconductors. We're growing the parts and structuring the parts and package the parts. And then we sell these components to our customers. So there's several types of photons coming out of semiconductors. First is the DFB laser, so very small bandwidth laser for gas spectroscopy. You can get them anywhere between 760, so where the infrared really starts, all the way to 14 microns. Diode lasers, interband cascade lasers, or quantum cascade lasers, very customized solutions. So if you have a question, if you have something very special you cannot get somewhere else on the market, I'm the right person to talk to. Some need a little bit more power. In our company, we talk about high power when there's 1000 milliwatt coming out, right? So not a lot of power for most of the applications here, but it's getting there. And if we're talking about bars, that could be interesting for a lot of person. This is where the bandwidth is getting broader. And then we have the SLDs. At the moment, only going to 2.9 microns. We did not realize them for the mid-infrared. That's going to come soon. So a very broader emission. And then finally, very new is the mid-infrared LED. So we can get every wavelength really between 2.8 and 6.5 at the moment. CW, 1 milliwatt, maybe 2 milliwatt in the future, room temperature in this very nice little package. So what you need for a whole system of tunable diode laser spectroscopy is a DFB laser like that, or a mid-infrared LED like that on the emission side, and then maybe some collimation and things like that, which you can see here. That is from a company from our Photonics, from Slava's group, where we have cooperated here to get the light into this hollow core fiber. Okay, so
thank you very much, Lars. You are indeed one of the nicest people I know. Thank you for always contrasting feedback on our meetings. Lars, you have a semiconductor laser. You said already that one of the challenges is to do the fiber coupling on the mid-infrared. You work already with the Slava on this. There are other challenges, and I believe one of the key challenges is to actually do the characterization in a system. I know Nanoplus wants to go sometimes up the value chain, so I want to find you a very nice partner. I'm going to go from Nanoplus to a company called MWIR. Pay attention to this company. It's one of the most innovative companies in mid-infrared detectors. Peter Totrov, thank you very much for being with us. Tell us what you do, and I'm going to find you partners.
Yeah, thank you, Jose. I will show you my slide here. Just a second. I'll take my screen. And here's my slide. I presume you can see my screen now.
Yes.
So here at NLIR, we do mid-infrared sensors that results in spectrometers and detectors. And we just recently launched a 130 kilohertz 2 to 5 micrometer fiber spectrometer. And what can we use this for? We use it for, together with Slava, also some probes, inline, online monitoring. And we have also done something for conveyor belts and plastic sorting. We have also done some coding measurements inline, where people in production use it for, they can see every time they layer some stuff on there. And we are also looking into OCT and DT, non-destructive testing, with the fiber spectrometer with the right light sources. So, I mean, we are the go-to guys from the 2 to 5 very fast spectrometers in this field. And what are we looking for? I mean, we have this one, and what we're looking for is collaboration with people like you to use this for.
And in a second, we're going to have the presentation of Luxinar, and then I'm going to go to Stratos from Guchan Hausko. We're going to find cooperations for you, but I already have the laser and the detector. And now I want to know about the coatings and the filters. And for that time, this time is, I'm going to be okay. Spectrogon all the way from Sweden. Thank you very much, Graham, for being with us. Tell us what you do, and we're about to find you very interesting partners.
Okay, thank you, Jose, and sorry about my technology problems earlier. Can you see that my screen?
Not anymore. Now we see it clearly.
Now you see it clearly.
Yes,
Apologies.
it's perfect. You can go ahead.
Okay, so Spectral are an optical component manufacturer. We're based in Sweden, although I'm in the UK. I'm sorry, I'm in a screen problem here.
Yes.
Yeah. Okay. Spectral's core business is and always has been the design and manufacture of interference filters for the mid-infrared, as defined by you, Jose, from 2.5 to 15 microns. Last week was Spectral's 30th birthday as an independent company working in this field, and the technology and manufacturing are all in Sweden and in the EU. We already supply many of the components that have been discussed today in this meeting. Eric from MWIR and LWIR kindly name checked us earlier, but we make WL wavelength packaging windows for microbolometers. We do high-end IR filters for IR detectors and gas detection for monitoring. What you can do for us, which is one of Jose's questions normally, is to get us involved at an early stage and keep the filter design, coating design in your mind at an early stage and not as an afterthought, because there are many trade-offs in manufacturing filters and specifying filters. Thin substrates versus flatness, tension balance coatings against flatness against price, customization level against quantities against price. So please include us in the discussion at an early stage in development, and we will try to help you with very good and a wide range of filter designs.
Graham, you have been one of the success stories of filters for the mid-infrared. For me, you should know that earlier in the meeting we had a challenge on how much mid-infrared power can go through the filter. Do you have some numbers, some idea into that?
That's a good question. I can't give you an answer. What I think the answer to that is it depends very specifically on the wavelength and the materials and the other factors in the design. So I think there is not a straightforward answer to it.
Okay.
But so that's something I'll investigate.
I think, Graham, do you have one extra slide after this one?
Yes, I can go. It's just a summary slide of the range. Again, we do a wide range of substrates, cover those full areas. The dicing capability, I think many of the people at the meeting will know that diced filters are the way to go on tape for pick and place for high volumes. That's something that's the wafer level packaging, which needs lots of other skills like clean production lines, low defects, automatic inspection, ESD handling. We have all of those. 100% optical characteristic verification. So I think covering the full range of requirements in this discussed in this meeting.
Thank you very much, Graham. And I'm going to now go to this that we announced already, but this time it works. We're going to go to Luxinar, and we're going to talk about CO2 lasers, which is the laser by itself in the mid-infrared. Let's go to Luxinar, understand what they do, most important, go around the table to see how we can help them do it best. The floor and the attention of everyone goes to Gavin Markili, all the way the technology stream manager of Luxinar. The floor is yours.
Thank you very much. Sorry about that earlier. So I'm going to talk to you today about wavelength band selected CO2 lasers. How do we do it and what are the problems? Okay, so I'll start with a little bit about the company, give you a background, and then we'll go into why we need the band selection, how we do it, some integration issues that come along, and so forth, and then find some applications. So who are Luxinar? We are a manufacturer essentially of CO2 laser industrial. That's what we do. We manufacture, I don't know, our revenue is about 50 million euros a year. We're about 200 people, and we think of ourselves as global. We're based mainly in the UK. That's where we manufacture our lasers, but we have offices over in the States, in Korea, China, and Italy and Germany. So that's okay. So the need for wavelength selection is a simple example. This is BOP, biaxially orientated polypropylene. You can see that this is a very thin film, and at 10.6 microns, essentially most of the light just travels straight through it. However, if you go to something like 10.25, which is doable if you know how to do it, then you can find yourself being able to get good absorption and actually machine very thin films. In essence, speeds in very thin films, you'll find that you can go much faster, and you may well find that the heat affected zone is much better when you choose the correct wavelength. Thicker films, particularly polymers, etc., then you're really looking at the effective heat affected zone as being the main benefit. Okay, next slide, please. Okay, so how do we do it? Well, there's a few options. Here you can see the spectra of the 3 different isotopes of CO2. The top one is the standard one, as you might assume. But you can make, for instance, 9.3, 9.4 microns just by choosing the second isotope down. But really, one of the issues there is you've got the problem of the adjacent branches, and that's quite difficult to suppress. So the route that we go is through band selection, and that requires us also to suppress the next door band. We've also got issues around proximity to the RF discharge. Our lasers are CO2 gas discharge lasers. So there's RF plasma flying around, so you've got to be quite durable to that and the high levels of UV that are generated in there. And also it's got to be quite a tough coating in itself. So really what you're finding is there are very few people or vendors that can supply us with these kind of optics that we need. And so that makes life quite difficult with regards to getting hold of them. If it was 10.6, it'd be straightforward, but 9.3 or 10.25, it is quite difficult. So far, we've managed to manufacture up to 450 watts rated powers at 9.3 and 10.25. Next slide, please. Okay, so you make your laser and then you let the end user and integrator loose with it, and then you start to find there are some problems. Sometimes you'll find that polarization is an issue, and standard 10.6 dielectrics, well, they're okay, but they will depolarize your circular polarized light. If you are using 9.3 microns, for instance, it's quite pronounced. Isolation is also difficult. So if you're then reflecting off a reflective surface, so it might be kiss cutting, etc., you might have something quite reflective underneath. You'll need to protect your laser. Protecting at 9.3 is going to be difficult because of the availability of the isolation optics. Again, very few people can make these kind of optics for you. That's been touched on earlier. As we start to work our way down in wavelength, we start to go into the absorption areas of water. Now, it's not terrible at 9.3, but it's much more marked than it is at 10.6. And so you've got to think about enclosing that beam delivery from laser through to the workpiece. You may have to have flowing nitrogen or dry air in order to get the process, the quality that you want. Otherwise, you'll see lensing effects. Really you won't lose any power particularly, but you may see your beam getting distorted. And finally, this loss, transmissive optics in particular, very reflective at 9.3 microns if you are trying to use standard 10.6. Now you might say, why would people do that? And the reality is that when we sell, we're not always sure who's going to pick up the laser and start using it. And often you'll find that there are problems in the field that you are asked to solve and resolve. And the realities are that it can be the most simple things that trip you up. And this is one of them. People not actually understanding you need the correct AR type coatings for the wavelength that you're running. In general, though, loss of those dielectric mirrors, standard ones at 9.3 and 10.25, it's not relevant. And so it's not a problem. Okay, next slide, please. So finally, just a few applications to give you a taster. You've got this one here. It's a 5-layer polymer based. You can't even touch this stuff with 10.6. It just obliterates it. But 9.3, yep, you can machine it. And we also use an AOM in conjunction with this to give us the kind of results that we want. So it's simply off limits with anything other than 9.3 microns. And then a customer-based driven sort of process where he's basically chopping up paper, okay, and he finds that the speeds that he go are much greater at 9.3 compared to 10.6. Not something we would have thought had any relevance or bearing, but driven by the customer at the end, the end user asking us for, that's what he wants, and that's what we'll give him if he wants it. Okay, final slide, thanks. All right, so just to summarize, certain materials can only be machined using these kind of optics, which, you know, we need those kind of wavelengths to get through them. You can buy 10.6, obviously, that's straightforward, but 10.25 and 9.3 are available up to 450 watts from us. Manufacturing characterization of band select optics, yeah, it basically requires you to collaborate with the people making these coatings. You may need to tweak the coating, work a few times on iterations to get it right. Because not only has it got to select what you want, it's got to do it efficiently and suppress what you don't want. And you've got to be mindful of the fact that who's going to use the laser and trying to educate them, or give them the relevant information, and be mindful about the fact that it is difficult moving from 10.6 to 9.3. It's not just simply about picking up the laser, a new laser from us, and sticking it into an existing machine. And that's it. Thank you.
No, thank you. Thank you very much for bringing CO2 lasers to a mid-infrared meeting for industrial manufacturing. It cannot be more relevant here because I have many people in the room who want to help. But as I promised, I want to do this Q&A together with a friend. I'm going to bring a guest, Stratos from Guch and Hausgott. Thank you very much for being with us. There is lots of room for cooperation here. Did anything resonate with you after you saw the presentation from Luxiner?
Yeah, so thanks very much, Jose. Thanks for giving me the floor. My name is Stratos. I'm the Chief Technology Officer of G&H. We are a photonics specialist. Our job is to enable new applications and enable more challenging systems. So I've been listening into all these presentations. I would say that our precision optical components line, we do flats, aspherics, cylindrical optics. We've got a range of coatings in the mid-IR going from 2 micron up to 12, 13, 14 microns. In general, our customers are mainly into the aerospace and defense, but also industrial applications for sensing and micro machining from a precision optical components side of things. But then what we do is we also use our optical components to make optical systems and imaging systems specifically. So we do use third-party cameras to do that. That's why it was very interesting to see a few of the camera manufacturers presenting their specs. What we do there is we manufacture systems that go on aerospace platforms, drones, near space for surveillance, monitoring, but also remote sensing. And we also have multi-band systems on armored vehicles. So not an industrial application, but we do make multi-band systems for and periscope systems on that respect. Now going back to the industrial lasers, then we do make quite an advanced series of acousto-optic modulators based on germanium, and these are mostly used in CO2 lasers. So our modulators usually have more than 50 watts per millimeter square of power densities. And they can work, and they are obviously you can modulate the signal to anywhere from 9 micron to 10.5 microns. So.
Stratos and Gavin, let me understand something. In the beginning of the presentations this morning, we had Femtum. I said morning because they're in Canada. They talked to us about their challenge with the coatings, with the amount of power that you want to put through this. And then I hear the presentation from Luxiner here. They say that they develop up to 450 watts, and they're looking for collaborations on filters that select certain bands. This is a huge challenge. Right, Gavin? Is it difficult for you to find the supplier of those filters? Gavin, Luxiner.
Yeah, definitely. It's a real challenge. Primarily, it's the length of time it takes to develop the optics and then to also qualify them. So the lasers themselves need to last 20,000 hours at least in the field. So you're going to have to live test a laser or 2 or 3 in different pulsing regimes in order to then qualify that your coating is going to survive. So yeah, it's the time, because once it's out there in the field, you can't have it fail. It's a real problem, as you might imagine. So
Stratos and all the other companies in the room, like Spectrogon, Iridian, I think there is clear room for cooperation here. I would like your coatings to be tested by Luxinar, and I'm paying for the shipping expenses of those coatings. So please make sure that there is a room for cooperation here, because we want to help Luxinar, member of EPIC, to develop this. And this is a key challenge also for other companies in the laser business. I also want to address another topic that, in my opinion, is very important. We have been talking about the characterization as a challenge. In the beginning, I went to spectrolytic. I want to go now to Nireos. I have Nireos in the room, correct? Yeah, Shang is in the room, of course, and full of energies. Shang, tell me what you do, but most important, tell me how this could be useful for the other people in the room, because we want to make sure that your spectrometers are used.
Thanks, Jose. At the moment, the spectrometers are still under development, but I would like to share my screen and I would like to show on our hyperspectral cameras, which we have recently developed. So as you all know, that Nireos is a spin-off company of Politecnico di Milano. We are based in Milan, Italy, and we are a startup company. It's the second year of our business, and today I would like to present our hyperspectral camera, which we have recently launched, and it is in the wavelength from 900 to 2.3 microns. And our hyperspectral camera is based on Fourier transform approach. And due to this Fourier transform approach, our camera is having high sensitivity, and also it has a very high spatial and spectral resolution. And our cameras are also capable of measuring extremely weak signals like fluorescence hyperspectral imaging. And compared to other hyperspectral cameras in the market like push broom technology, our camera is starring technique. All you have to do is mount the camera on a tripod, you stare at the screen, and you take the hyperspectral images. So the one which you see in the presentation is the extended SWIR. And also we have 3 models of hyperspectral camera, which ranges from the VISNIER, which is 400 to 1 micron, and SWIR, which is from 900 to 1.7, and extended one goes till 2.3. And in the future, we are planning very soon to launch multi-band spectrometer, and we are still in the development stage. So thank you so much for giving me the opportunity.
You do very, very interesting cameras, but I would like to apologize to everyone. This meeting is from 2.5 to 15 microns. The reason why I gave you the floor is that we want to collaborate with you in your spectrometers for multiband. This you announced already. I understand you cannot talk too much about it in public, but I believe there is room for cooperation with Luxinar on this. So I actually would like to ask you to get in touch privately. The reason why I gave you the floor was because of that. But I also want to address now Stratos. Do you know the huge boom that we have now in Europe on adaptive optics? We have made a huge boom on these companies like Imaging Optics are doing great. Companies like Dynamic Optics are doing great. Companies like Phasics are doing great. I think Phasics is in the room, right? Yeah, Joan is in the room. Joan, tell me about adaptive optics and what is the role of industrial manufacturing, and explain the people why I get so excited when I talk about adaptive optics, wavefront sensors.
Yeah, of course. Let me share my screen. Okay, good. Can you see the screen now?
Crystal clear.
So at Physics, we propose adaptive optics solution, as you mentioned, but one of the key parts of the adaptive optics is to correct the wavefront aberration. So the key things we do at Physics is actually we focus on wavefront measurement. We focus on wavefront sensors and also optics testing station. So Physics was created in 2003, is ISO certified, and is composed of 40 employees roughly. We have our headquarters R&D and development in France, and we have sales and support office in the US, where I'm working from. So what can Physics propose for the mid-IR photonics community? So we can propose, as I mentioned, a unique actually wavefront sensor. We are the unique company that can propose a wavefront sensor that's working in mid-wave, so 3 to 5, and long wave, 8 to 14 micron. So it's called the SID4 DWIR. And a single instrument like that can address wavefront measurement application in both of those wavelengths. Then what we can also do is we can integrate those wavefront sensors in adaptive optics. But to be honest, in the mid-IR adaptive optics, it's not that common yet, maybe in the future. What could be interesting, so, is to integrate those wavefront sensors in test stations to characterize optics, characterize coatings. We are talking about filters. One of the things is you want your filter to be able to not distort when there is too much power. When you are applying the coating, you don't want to make sure the image quality is not going to be impacted when you integrate those filters in an optical system. So what can we do with those wavefront sensors? We can do optics testing. So measuring the transmitted wavefront error, measuring surface figure error, measuring modulation transfer function. And this applies to lens, filters, mirrors, but also sub-assemblies and assemblies. And the big thing is we can do that not only in the visible, like a lot of people are doing, but also at their working wavelengths in the infrared. And the other application is really to we've been talking about those ultra-fast lasers, CO2 laser. We can provide solution, wavefront measurement solution that's going to give you the capability to qualify the quality of your laser system, of the wavefront, of the intensity, and of the beam parameters of the laser. And we can measure that in a single shot. So this could be applied to the laser itself, but also to the beam delivery system. And then the reverse question is like, what are we looking for at physics? So there's more and more projects in the SWIR, in the MWIR, in the DWIR. We are looking for like new cameras that we can potentially integrate and turn into wavefront sensors. We are looking for laser sources and optical components that we sometimes need to integrate in our optical test bench.
Thank you very much for that. This is the perfect one slide. Lars from Nanoplus. Listen, this was the perfect one slide, an example of how to do one slide pitch of their technology and you're looking for partners. So I would like to ask you now, Stratos, back to Guch and Hausko. We are talking about the need for characterization, the lenses, the optics. And one of the key main suppliers for the camera manufacturing business, is there still challenges on the characterization of the optics, the validation of the optics that you think adaptive optics technology could have an important role, especially in the mid-infrared?
Yes, there is. Obviously, I can't. There are limited things I can say in public, but obviously there are challenges still, not only on the characterization side, but also on the time required and the automation around the characterization of such systems.
I also want to make sure that the adaptive optics boom that we have in Europe gets promoted further. So remember that Johan came to the meeting looking for partnerships here. So please get in touch with him. We are going to make lots of introductions after this meeting, Francesca. But now it is time to go to, we saved the best for the last, I believe. It's time to go to one of the key success stories that we have in Europe. We are going to talk about how the fibers of Le Vert Fluoret have made a difference, a huge difference on the laser industry in one of the most interesting 3 micrometer CW laser fiber sources that we have in Europe. We go to LUMIR because we want to understand how to make LUMIR a racing star, racing even brighter the floor. And the attention of everyone goes to LUMIR lasers.
Thank you very much. So I know I'm the last presenter today, so I will try to hype everybody up and give you as much energy as you need to start your vacation properly.
Oh, they're full of energies. Look at them. Look, everybody's smiling.
I mean, if I have just a fraction of your energy, Jose, I think that'll be enough to feed everyone. All right. So can you see my screen right now?
Crystal clear.
Perfect. So yes, thank you very much. So my name is Louis-Philippe. I'm the co-founder and CEO of MWIR and Lasers. And I hope I can hype you up about lasers today. So as we mentioned, MWIR Lasers is a startup company. So we're established in Quebec in 2019. And basically what we're trying to do is we're trying to bring to market the first truly disruptive suite of powerful and low-cost mid-infrared fiber lasers. Now, that will be ready for your applications. Now, of course, this is the Mid-IR Alliance. I don't have to tell you why the mid-infrared is amazing. You know, we got the molecular absorption bands, the atmospheric transparency window. But I can tell you how and why what we're doing is different. And it starts with the people. And this was mentioned earlier. So what we did basically is that LWIR is essentially a joint venture. So on one side, we handpicked some of the top people that have worked in the field of research for mid-infrared fiber lasers over the last 15 years, essentially the people that have been dominating this research space. Notice that I've humbly excluded myself from the family picture here. But I do encourage you to look up these people, see what they have done. And then on the other end, we have as a founding partner, Le Verre, who basically invented fluoride glass fiber. And this partnership basically allows us to control everything that goes from the very start of making the fiber all the way until it becomes a laser and goes into an application. And this sort of integration is something that is unique and new to LWIR, and it gives us an immense power innovation, but also immense power over our cost structure. So more specifically, some of the things we do, I won't lie that right now the star of the show is the 2800 series. This is more of a medical, I think, device, more interesting for medical devices because of the high absorption in tissue. But the advantages that are brought are similar from one laser to another. One of which is that, of course, we're able to reach high powers and we're able to focus them in a single mode beam, which is basically gives you the highest beam quality that physics will allow. And that allows you to focus your beam in such a small spot that you have high intensity and very high precision. And in the case of the medical, for example, you can do surgery or aesthetic with no bleeding, no burning, less pain, etc., compared to anything else that's in the market. But LWIR, of course, has a grand vision. We're building lasers that have longer and longer wavelengths. One of the other lasers that's available right now is goes all the way up to 3.3 micron. I know it on our website, it says coming soon, but the website is being remade right now. So yes, you can purchase this laser. And we're even working to bring it all the way up to 3.4 micron and above. Which actually brings me to my next point, which is that LWIR aims to provide fiber lasers for basically all the wavelengths all the way up to 4 micron. We want to be the first company to do that with pulse versions for everything as well, and not just CW. And one interest of going, for example, to 3.4 micron in the case of industrial is that you're able to perform resonant ablation and cleaning of polyethylene. Now, polyethylene is one of these polymers that lacks absorption bands within the range of the CO2 lasers. So if you're trying to clean something that has polyethylene on it and you don't want to damage the surface underneath, it's basically not doable right now with what's available in the market. But when you go to these mid-infrared wavelengths, you're able to vaporize it with no damage whatsoever. And here I am trying to talk too fast, but this brings me basically to the point of the meeting, which is our problems and the partnerships that we are looking for. So LWIR Lasers is a manufacturer of lasers. We innovate in lasers, but we are not manufacturer of laser systems. So if you are interested in mid-infrared and you are a system integrator and you work with processing of non-metals, sensing, countermeasures, surgical and aesthetic, do get in touch with us because it helps us do two things. The first thing is it helps us know exactly what the market needs in terms of new technology as we bring more and more things into the market. And the other thing is it helps you because we are able to give you an edge in your market if you're into any of these applications right now. I would also add that if you're an academic and you're interested in doing mid-infrared experiments with lasers, we have special discounts for academics, and we ourselves are looking for suppliers as well. So we are looking for more supplies of coatings on zinc selenide and index polymers. I've noticed so far that in the meeting there have been several people that seem to delve in these sort of things. So do get in touch with us, and hopefully we can get a collaboration going. And thank you. That's it for me.
Thanks a lot. Thanks a lot. So it was a nice shopping list. So that's we know that we put a lot of course challenges on the floor and on the stage today. So that's good that you also brought yours, and then we keep them in mind. Now all the world knows. So let's please talk with him as well also, and about the optics and the coatings. So that's a good point. Now it would be nice for me because I guess we have Samuel from Librera in the room. And maybe it would be nice to give him the floor as well, so that he can give a bit the vision from the side of the supporter, so that we can also see maybe a bit of history and also what Librera anyway does a part of supporting LWIR lasers. Samuel, are you there?
Yeah, thank you. So I did not prepare a slide. I just wanted to send a message. Last time I was saying that fluoride gas technology was becoming more and more mature. I confirm this point. I'm really impressed by the growth of this market. We can expect by 4 or 5 years more than 1,000 per year units market just in mid-infrared fiber lasers. So yes, this is a new ecosystem, a growing one, and we are very happy to see that there are more and more companies, Louis-Rafaël laser, but also Femtum. They are very innovative for new laser, and we are very happy to see this ecosystem growing. And let's join this ecosystem.
Yeah, thanks a lot. That is also our impression. That's the same, and that's why we are with this Mid-Area Alliance, even to bring it further, and then to really make it also more common to those that don't think yet it's something that is useful. But for example, we heard from Physics, they think that adaptive optics, there is no market yet. So, but that is the push, right? So do maybe have the laser manufacturers here, so like Femtum, but also Louis-Rafaël, if you have some questions more towards this kind of lenses or this kind of optics. Of course, you're talking about selenium, ZNC, yeah. And but what is the other challenges that otherwise we didn't touch today? There is some. Is there something that where we're gonna go to? Maybe towards the application, because we heard. Maybe we go back also to the material. So we heard a lot about metal today, but also of non-metal material. Is there something where also the supply chain can help you? Can someone maybe comment on this? I don't know if it's Louis-Rafaël or we are both called Louis, and so that's very complicated for me.
Yes, it's a typical Quebec thing to have compound names. So I can go by LP, for example. That's usually easier for everyone.
Exactly. That's very good. So now, but so what is your feeling? So where is that towards your application? Where are the challenges that we maybe didn't discuss too much today? Because of course it's good we talk about the supply chain. That's very good. But do you have maybe some feeling, something where also EPIC as your association, as EPIC members, can help you with towards bringing some new end user to the floor for the next meetings, or someone you will really like to talk to for applications?
Excuse me, this is a question for me?
No, it's actually for the Louises.
Oh, okay.
But, so well, please, one of you.
I can talk. Louis-Rafaël, if you want to jump in, feel free to do so as well. On our side, I think one of the challenges that we've had to face, and I think it's one of the same things for Femtum, is part of what we do is what we have to do is educate the market, which is something that events like what EPIC is doing contribute to, because a lot of the times when people have applications or industrial applications that have been in the market for a long time, be it, on a factory line or in a medical, people have been used to using certain types of technologies, and all the experiments that they have done in the past have been using those technologies. So CO2 lasers, erbium YAG lasers. So a lot of the time we have to break a wall when connecting with those people, because we have to make them understand that outside of what we are proposing is outside the realm of everything that's been done before. So in that sense, I think one thing that EPIC can help us do is to connect us with people, of course, that are relevant to the applications we mentioned, the medical, the industrial, but finding the right people is important. If you talk to sometimes, and that's been my experience so far, if you talk to some managers sometime, usually the knowledge of the technology that they have, like I said, is related to lasers that are already in there. So they'll say, oh, we're looking for these technical specifications, but these are the technical specifications of the lasers that have been in the market for the last 20 years. So it's finding the right people that have the technological knowledge in each of these business sectors to understand what we bring to the market and give us a chance to show that we can significantly improve not only the technology, but people's lives as well.
I think that Louis-Philippe is very right, and that's why also Femtum, we have our own application lab. So the goal is really to demonstrate the application. So it's one thing to claim, let's say, oh, we have a good laser, but to prove it and show real results to the customers, I think it's very important, especially with novelty lasers. So that's why, let's say, we do have an application lab, and now we make a lot of samples for a lot of people right now for this exactly.
Thanks a lot. Thanks a lot from these comments about the application. So I believe that we didn't hear yet from Jörg from DLAS Coherent. Is it correct? And I know he was planning to tell us something. Jörg, are you in the room?
I am.
Yes, there you are. So, so nice to see you also today. So I guess you were planning to say something a bit the DLAS opinion about this wavelength range, and maybe also of course your vision for this kind of sector and for the activities we are doing on industrial.
I can share my screen.
Sure, you can.
Bear with me. And so it should be then this one. So you could see my screen?
We do, so there you go.
So yeah, we work on this range, actually not the full range, but up to 2.3 micron. And I have to confess, we already made more than 3 microns. There's definitely issues in that range for us, coming from high power with cameras or power meters. So all our equipment essentially is not yet fully optimized for above 2.3 micron. But we produce these gallium antimonide based materials here in Europe, and we produce them either as single emitter, as laser bar, or even stacks. So for example, on the lower right, you see a 10 bar stack, CW going up to 140 watts per stack. We produced it at 1940, but also at 1908 to pump a holmium crystal, for example. The single emitters are often used also in pulsed mode. And you could see in the upper right, you could see the power levels we achieve. Red is CW, so like 1.5 watts, and 2.2 micron, it's more like 750 milliwatts. But in pulsed operation, it actually can go like a factor of 2 to 3 higher. The applications which, I wouldn't say we target, because here we are opportunistic. We really depend on customer inquiries. Applications range from medical, but also defense applications. As I said, 1908, you can pump holmium. You might be able to use wavelengths above 2 micron in a window of the atmosphere for infrared countermeasures. You could also use these types of wavelengths for gas sensing, like checking pipelines or stuff like this, if there's particular gases coming out. So from that point of view, I just wanted to mention we are kind of on the short wavelengths end of the mid-IR, and just wanted to let you know where we stay. We are also getting inquiries for fiber coupled versions of that, and especially above 2 micron, we are looking for micro optics, which is transparent for this type of wavelengths, but also fibers. So that would be just a short summary of our gallium antimonide activities. Thank you.
Thank you very much. So next time we have to help you to overcome these challenges you have, so you can also bring us towards the mid-IR, the real one, right? So very good. Eric, yeah, you have a question, right? You have your hand raised from Aranova?
Yes. Yes, I have a question for you. You said on the slide that you are all you are doing everything in EU, in Europe, even the epitaxial growth.
Yes.
Okay, you have a good partner.
What do you mean with a good partner?
Because you mentioned that this is MBE growth, and the MBE growth for gallium antimonide based superlattices, it's not heterostructure, it's not that common.
It is not common, yeah, but it's all made in Europe.
Okay. Congratulations.
You know, congratulations to all of you, It was the first online technology meeting on the Mid-Infrared Alliance, and we really did bring some of the key companies in the sector. I'm extremely happy that we addressed some challenges on the filters, on the monitoring, on the fiber and the CO2 lasers, and the adaptive optics. But you know, the most important part of the meeting is now, when you actually have to follow up with each other. I want everyone now to find which are the 3-4 companies that could actually do business with and interact with them. That is going to happen now. But first, let me tell you something quite important. And that concludes the public part of today's meeting. If you are in our Zoom room, our informal private discussion is about to start. I call it virtual drinks with friends. And we all know follow-up is important. But for now, if you are watching on YouTube, that's where we leave you for today. Thanks to the epic production crew and our sponsors for making today's event possible. More details about upcoming meetings are on our website. And if you want to get in touch with any of the participants, all you have to do is contact me directly and I will make sure you get introduced. It is all about connections. Thanks for being epic.